all these important pieces. The definition of a rational function is a polynomial in the numerator divided by a polynomial in the denominator. And there's an example on this slide. You don't need to write it down. I'm going to show you how to graph these. So you're going to have this polynomial, 3x squared plus 6x plus 3, and then x squared minus x minus 2. What they're going to look like is you're going to have these vertical asymptotes and these horizontal asymptotes, and then these curves. And we're going to teach you some ways to find these asymptotes and find these curves from the function without a calculator. These steps you don't need to write down. If you want to write them down, you can now. They're going to be in your next video's examples. But I just want to talk through it. Number one, we want to identify the domain of the graph. So we're going to say, what does the denominator not equal 0? To find that vertical asymptote, we're going to set the denominator equal to 0 and then solve for x. Then your graph might have a horizontal or slant asymptote given these three rules. If the numerator is smaller than the denominator, then you'll have an asymptote horizontally at y equals 0. If the numerator and denominator's degrees equal each other, then you're to divide by the leading coefficients. If the numerator in the degree is greater than the degree in the denominator, then you won't have a horizontal asymptote. We do need to check to see if a slant exists. A slant is something like this in a graph. If the numerator's degree is exactly 1 more than the degree of the denominator, then you're going to have a slant. You're going to use long division and ignore the r. And it'll be in the form of a line. Y equals mx plus b. Note, if there's a slant, then there's no horizontal line existing. To find the X intercepts, they are going to be the zeros of your numerator. The y-intercept, you're going to let x equal 0 and then solve that equation for y. Symmetry, we've talked about this a couple times already this year. You look at the equation and you want the original equation back. So you're going to find the x-axis symmetry, replace it with negative y. For y-axis symmetry, replace the x with negative x. For origin, you replace both. And you want this original equation back for you to have that true symmetry. Then you may need to plot a few additional points in an XY chart if needed around those asymptotes.